Hello, welcome to By Excellence Tutorials. So if you've not yet subscribed to the YouTube channel, kindly subscribe to the YouTube channel and don't forget to click on the notification bell so that you get notified each time a new content is uploaded. Here at By Excellence Tutorials, we tutor courses such as mathematical methods, physics, chemistry, biology, statistics, and many other courses. So if you happen to also look for a tutor, a private tutor, you can get in touch with us and we'll be glad to be of your help. Okay, so in this video, it's basically the continuation of what we started under differentiation. So in the previous video, we looked at differentiating functions using the limit definition. Okay, we're using the definition of limits to get our derivatives. But in this video now, we're going to introduce other methods, okay, or other differentiation rules that we are going to use in order to find the derivative without using the direct use of the limited definition. Okay, so the first rule that we're going to talk about in this video is power rule. How do we get to use power rule? Is power rule difficult? Okay, let's get to see. So if we have a function, y being equal to x to the power n, of which we have a and the n are real values. Okay, they're real values. We can find the derivative of this function by, well, we have a n minus 1. Okay, this we've done is what is, so we are dealing with the power here. We are dealing with the index n. Okay, you can see that when differentiating, we've dropped n and subtracted 1 from the power. Okay, so we have a is a constant. A is a constant that we are not differentiating. So we are differentiating x. So we get to drop the power of x and then subtract 1 from the power. So that is what power rule is. So, okay, let's say we have a function y equals to x to the power 3. With respect to x, it's going to be, we drop the power 3, okay, and then to be 3x to the power 2. We have differentiated like that. Okay. Let's say we have power 4. How do you differentiate that? So what we have to be 2 times, we drop the power 4, and then so we're going to have 8x to the power 3. Remember, this 2 here represents 4 is representing n, 2 representing a. So when you drop n, you get to multiply it with a. So you don't forget that one. You get to multiply it with a, and then you have differentiated. Okay. So y equal to 7x cubed. Differentiate that one using power rule. So pause the video for just 1 minute. You should be able to differentiate that one. Even in your head, you can differentiate it. Okay, I believe you paused the video and you tried it out. So this one, changing y with respect to x is going to be 7 of x 3 minus 1. So the power 2. And you have differentiated that one. One thing that you have to also note is that when you differentiate a constant, you get a 0. Okay, when differentiating a constant, you get a 0. So if you're saying you're differentiating 4, you want to differentiate 4 with respect to x, because we don't have that variable x there, or 4 does not have a variable x, then it's going to be 0. Okay, so we have this one. How do we get that one? So you change this one from radical form, okay? From radical form, you bring about the power. So this root x is the same as x to the power 1 over 2. This one, we are going to drop the power, which is half minus 1, negative half. We have differentiated. So you can also differentiate using power rule, this one. In 1 minute, you can try to differentiate that one. How do we get to differentiate that one? Okay, so this one is going to be x to the power half like that. So that times the power, which is half. Then we have 3 over, simple as that. So this is how you differentiate using power rule. Okay, so now power rule can also be used if you have an expression that has got more than one term. You can see that we've been dealing with one terms, okay, single terms here, but you can use it when you are dealing with also different or many terms. So if you have an expression, for instance, 2x minus x plus 5x squared, you can use power rule to differentiate that expression. Okay, what you need to do is to apply the same principle, the same concept on each term. Okay, on each term. So if you are summing or you are finding the difference, subtracting, you use power rule on such functions. Let's look at what we are talking about. So let's say you have a function y as 4x plus 5. Okay, so this one has got different terms. It's got 3 terms actually. We can use power rule to differentiate this one. So here, which is 3, and then we have x minus 1, and then minus power. What's the power there? It's 1. 1 plus, we've said when you're differentiating a constant, you get 0. In other words, since you have 5 here, we don't have x. If we say we put x to the power 0, because x to the power 0 gives us 1, so we have not changed anything. It's going to 5, and then we drop the power, which is okay. We've just put the x there, the power 0, but you know that it's giving you a 0. So I just wanted you to know where the 0 is coming from there, but how? It's just coming from nowhere. Just say it's a 0. So this is how it comes about, because the x is not there. So you can say x to the power 0, which is 1. It's not x to the power 0. Okay, so we get 21 here. For 1 minus 1 on the power here, we get 0. And any number later to the power 0, it's 1. So we are going just to have a 4 there. And then here, we are multiplying by a 0. So everything is going to vanish because we have multiplied by a 0. So x squared minus 4 once we differentiate that function. Yeah. Let's look at another example. Example 2. So f of x over 2x squared. How do we differentiate that one? Okay. So we have change in y with respect to x. It's going to be, we drop the power. Okay, we drop the power here, which is 4. And remember, we have a minus. Okay. This is over 2, which is 3. Then we have x, drop the power, which is 2. Okay, and then we have x. We're going to have here is, we can say 2x, 4 minus 1, it's giving us 3. And then here we have our 2. And then here we get minus 4x. So you found the derivative of that function that we have. So this is how we get to use power rule when we are finding the derivative. Okay, so if you found this video to be helpful, kindly share and react to this video. And in the next video, I think we are going to look at power rule. We're going to look at product rule or quotient rule and chain rule as well as we go on. We go on dealing with differentiation, the basic differentiation rules. Okay, so thank you for your time and see you in the next video.